When you think of a particle accelerator, you probably think of a machine like the Large Hadron Collider in Switzerland, looking for new kinds of subatomic particles. But most accelerators aren't used for particle physics. We're going to find out how to use a particle accelerator to understand materials at the Rutherford Appleton Lab in Oxfordshire. Here, the ICIS particle accelerator is used to try to understand the physics and chemistry of materials, from those in the microchips in your computer or mobile phone, through to the advanced alloys used in aircraft wings. Here at ICIS, we use neutrons to look inside of materials. This is possible because neutrons have no electrical charge, which means that, unlike my hand, they pass through matter almost completely unimpeded. Luckily, they're not totally unimpeded, and in fact, their gentle deflection can be measured, and that allows us to work out exactly where atoms are positioned and how they're moving inside of materials. This building here is called Target Station 1, and it's full of instruments which are designed to analyse how neutrons behave when they pass through materials. All of the machinery that actually does any physics is hidden inside these bunkers with walls made from blocks filled with wax, because neutrons are pretty radioactive, and it turns out that wax is the best way to stop them escaping into the wild. So where do we get the neutrons from to fuel all these different experiments? Neutrons are normally tucked up safely inside the nuclei of atoms, which means they're pretty hard to get at. The way that we get them here at ICIS is by smashing a beam of protons into a tungsten target, which is behind this blue concrete and steel shielding behind me. The protons smash into the tungsten and create a shower of neutrons, which can then be directed to the different experiments that are being performed around this hall. I want to show you how we get the high-speed protons that we use for this collision. I'm going to take you to the ICIS particle accelerator. Behind this security door is the particle accelerator. It's a huge circular room, 160 metres around, and it's where we start on the journey to creating neutrons. I asked Dr Suzie Sheehy, an accelerator physicist, to tell me a bit more about how the machine works. So Suzie, how fast are the protons going in this accelerator?
Well, when they come into this main ring of the accelerator, they're already going at about 37% of the speed of light. And then after we accelerate them in this ring, they get up to 84% of the speed of light.
Wow, that's pretty fast.
Yeah, it's pretty good.
What do all these boxes and gizmos and wires do to get the protons going that quickly?
So the biggest ones that you'll see, the yellow ones over there, are called bending magnets. And all it does is keep the particles going in a circular path as they come around the accelerator.
So how about this green box here?
So they're called quadrupole magnets, and they actually do the focusing of the beam of particles. So it allows us to keep it nice and tightly squeezed down so that we can keep control of it and not lose too much of it as it goes around the machine.
And finally, these silver ones, they're quite important, right?
The silver ones are probably the most important bit. They're called radio frequency cavities, and when the particle goes through it, it gets a bit of a kick and it gets accelerated. And we've got a few of those around the machine as well, so each time the particle comes around, it gains a little bit of energy, so that after many, many turns, it gains its full energy and gets up to its top speed of 84% of the speed of light.
I mean, you know a lot about this accelerator, but this isn't your real job, is it?
That's right, yeah. I don't know all there is to know about this machine, because what I actually do every day is design smaller accelerators. So what I'd like to do, you probably notice how big this machine is.
It's pretty huge.
What I'd like to be able to do is to build a smaller machine which can do the same job.
How small could your accelerators be?
So the one that I'm designing at the moment is probably about 10 metres across, so a lot smaller than this.
While physicists like Suzie work on designing new kinds of accelerator, large facilities like ICIS will continue to help us to understand how materials work, using the shadows of ghostly neutrons. And this can help us to develop new technologies to make stronger and lighter aircraft, or just to fit even more music onto your MP3 player.